All right, so this review is just going to be the 2 quizzes. We only took 2 quizzes this chapter, and so I took everything. I've actually made the test up, and I actually took it myself, and I got an answer key and everything else.
What did you get on the original test?
I got 100. Actually, on the quiz, when I did the quiz I just turned back to you, when I did the answer key thing, I actually got 2 wrong. And it was just because of stupid things. It was like, one was I didn't change the direction of the inequality, and the other one, I forget what it was. It was real dumb. Maybe I didn't make my line straight enough or something, and I got off. I don't know what it was, but I had to go back and fix it. So I thought, oh, that's not good. But I knew how to do the problems. It's just, anybody can make a silly mistake. No matter how good of a student you are or a teacher, anybody can make a silly mistake. Just like Mia, she just discovered her silly mistake. I know that sound. I like that sound, actually, because it means that you figured out what you did wrong. That's learning, and that's what's good. All right, let's do this. I don't think we have time to go over everything here. All right. So, like 7 and 8 on this quiz? Elimination? Well, this is the first quiz. Let's just take a look at it just so you can see what's on there. All right. Now, I will tell you, some of the problems have the exact same numbers as some of these, right? And some of them are different, all right? I did take everything from the homework, all right? So everything that's on the test that you're going to take tomorrow is directly from your homework problems, all right? So if you've gone over your homework, a lot of people, I turn the homework back, they crumple it up, they throw it on the floor, or they throw it in the trash can, which is just as bad. Well, it's not just as bad, but it's pretty much just as bad. But your homeworks you can use to study from, all right? If you actually tried your homeworks and if you actually wrote down the answers, you can go back and look, and you're going to see those problems on the test, I guarantee. Except for one. I changed one because it went way off the graph. I made it shorter so it fits on the graph. But other than that, I think everything is identical to your homework problems. Okay. Do you want to do the quiz I just turned back first and then go back to this? Okay. I mean, this is pretty... Let's just scan this really quickly. This is kind of like what was on the quiz you just took, except what's the difference between these 2 problems and the problems you had on the quiz? The first quiz. Yeah, this is equals. It's not inequality. Right. It's just the equal sign. No big deal. Same thing with this. It says solve graphically. Now, the quiz I just gave back to you, you had to do the shading, right? What is this one, though? They're going to do what to each other? They're going to intersect, and you just find that point of intersection, okay? Everybody with me on that? So you just graph them, they intersect, find where they intersect. Make sure you bring like some kind of a straight edge, okay? Bring like maybe an index card, maybe a ruler, okay? I keep a ruler in my bag that I have my computer in because I'm always... If you look at this, I got nice straight lines on there because I use a ruler. All right, that'll make it much more accurate, and so you know you're going to get the right answer. So don't just take it and just go whoosh, whoosh, with your lines, because on some of these, you really got to be accurate. So make sure that you have a ruler or some kind of straight edge, all right, to do that. All right, substitution, you know how to do these. I mean, we've done the 3 of them, right, on the second quiz. These are just 2 equations. And you can see, now it says to do it by substitution, which is probably the best way anyway. That's probably the way you would want to do it on these. And this says do it by elimination. Again, same thing. This is probably how you would want to do it. You'd probably want to do it algebraically or elimination. Now this one, you can choose whatever way you want to do it. Everybody got that? Okay. So I don't really have to go over those problems, I don't think, do I? All right, let's do this.
Can you go over number 9?
Okay. What about earlier? Anything earlier? Most people got 1 and 2, right? 7, 8, 9, and 10? Okay. So you want to concentrate on those? All right, let's do 7 and 8. All right, let me get my little writing thing here ready to go.
Actually, I got 7 right. I just didn't put an answer.
You got it right and you didn't put the answer.
Yeah, like I had it, but I didn't put the answer.
Why didn't you put the answer?
I don't know. I thought it was wrong, but I wrote the right answer.
Oh, goodness. All right, so you got to do a few things here, and this is what I checked. It says graph, all right, so graph all this stuff right here. That's what the constraints are. And shade, all right, some people didn't shade. Marked off for it, okay? the region, all right, and then find the vertices, all right. So you got to find that, and then you got to do the maximum or minimum, whatever they ask you to do. The first one was minimize, second one was maximize. Okay, so let's do this. X is greater than or equal to 2. So how do I graph that? Well, I go to 2 on the x-axis, and what kind of a line is that going to be? A vertical line. Okay? Everybody with me so far? Okay, x is less, and there is shading involved. We're going to wait to the very end, okay? I'm going to graph all my lines, and then we'll do that all at the end. So x is less than or equal to 5. Looks the same thing, except I go to 5. 3, 4, 5, right there. It's a vertical line like that, okay? So it says x is greater than 2 and less than 5. So far, now I got 2 more things to graph, but so far, what's being shaded? Everything where? Between those 2 lines, okay? Right? Because it's greater than the 2, less than the 5. Everybody with me on that? Okay. But we got some more constraints, right? Some, I was thinking of another word and I can't think of it now. Anyway, there we go. Clicked off of it. Y is greater than or equal to 1. So what's that look like when it says y is greater than or y equals something? Oops, why did I do that? Oh, let's get rid of that. Okay, sorry. So y is greater than 1. So this is a horizontal line that crosses y at where? At 1. Okay, so let's draw that. And these are all solid lines, correct? Some of you guys, don't I mention it all the time when I do these solid line, dotted lines? Okay, some of you guys aren't thinking about it, and some of you guys are just putting solid lines every time and not putting the dotted lines, okay? I have to mark off for it, right? Sometimes I forget to do that myself, but you're taking the quiz. You're getting graded for it, all right? So you got to make sure you know how to do it. What does this say? Greater than. So it's everything between these 2 lines, and it's everything above this line. So really, this is the shaded part so far, correct? There's one more thing, though. Y is less than or equal to the absolute value of x minus 1. How do we graph that? You go down 1, correct? When it's outside of the absolute value, that means you go up and down. And then what's it look like? What's absolute value look like? Like a V. Here's what I would do. You go up 1 over 1. I'm going to keep doing that until I just get to the end of the graph. It just makes my line a lot more accurate that way. Okay? And you could boom, 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 right there. Does that make sense? It's just a little more accurate. And you want to be accurate with this because there's one particular point in here that you got to know where it hits. You got to know that it hits right there. That's the key point to that, all right? And so is that one too, really, all right? So what am I shading? Everything between these 2, above the y and the, oh, by the way, I'm sorry. Yes, you're right. I got ahead of myself. So it's like this, and then let me click off of that, and then it's like this. Right there. Yeah, that's what it should look like. Sorry about that. But really, did it really matter, though, with our shading? Because we're only going to use this part anyway. All right, so this really didn't matter. But technically, that is the graph of this, okay, of the absolute value. Now, what are we shading? We're shading everything in between these 2, above the y, and then below, right, less than or equal, this slanted one right there. So what's shaded? It's just this stuff in here. Okay? So that's part of it. All right, part of it says to shade. That's the instruction. So you need to shade it in. Okay, now we're going to find the vertices. Where's the vertices of this shaded in part right there? Well, there's one right there. There's one right there. And there's one right there. Can you see that? Maybe I should go a little bit. Is that a little easier to see? Okay? So what do we do with those vertices? This is where we do the maximum minimum thing. All right? So let's list these 3 vertices. Let's list this one right here. What is that? 2, 1. All right? So 2, 1. I'm going to write down. What's this one right here? 2, 3, 4, 5, 1. Yeah? And then what's the third one? 5, 1, 2, 3, 4. All right, what do we do with those points? We're going to put them into this, okay? Then once we put it into there, we're going to get 3 values. We're going to look for the one that's what? The smallest one, because it says minimize, okay? So let's put the 2, 1 in here. So let's just write it out. 2 times what? I'm sorry, I got ahead of myself again. 3 times 2 plus 8 times 1, right? Because this is x, this is y, this is x, this is y. So I just put them in for this. All right, that 6 and 8 is what? 14? All right, so that's what that one is. Let's find the others. 5, 1. So it's going to be 3 times 5 plus 8 times 1. That's 15 and 8. What's that? 23. All right, well, so far, what's the minimum one? 14. Let's see what the next one is. 5, 4. I have a feeling this is going to be pretty big, right? Because I'm not subtracting anything, and I got bigger numbers, so it's 3 times what? 5 plus 8 times 4. This is 15, and that's what? 32. What's that? 47? Is that correct? Yeah. So again, what do we look for? We look for the minimum, the smallest one, which would be this one. This is really how they want you to write it. So they want you to write f of 2, 1 is equal to what? 14. I think somebody just wrote down 14. I think Hunter did, and he asked me if it was okay during the quiz. I'm like, yeah, okay, I guess that's okay. But this is how you really should write the answer. And a lot of you guys did write it like that, which is good. It means you're paying attention. What do you think? It's not hard, is it? Is it? Okay. Are you okay? Do I need to do 8? 8's kind of the same thing. All right.
So when it's greater than, it's above the line or to the right of the line?
Yeah. If you didn't know, you could always pick a point to see if it satisfies it, right? But yes, think of it that way, all right? So if it's vertical, if it's greater than, it's to the right. If it's less than, it's to the left, okay? And if it's slanted, above is greater than, below is less than. And obviously, if it's horizontal, above is greater than, below is less than. Okay. Everybody good with that? The next one, though, there was a little, I don't know, did you notice what I put on some of yours? Oh, no, it was 6. It was number 6.
Oh, yeah, you circled like the line.
Yeah, well, I didn't circle the line. There's a little section that should not be shaded, and some of you guys shaded it. So here, let's just do this quickly. Let's do the x and the y ones first. So y is greater than or equal to 0, so that means you have, that's a horizontal line, and then this is a vertical line. Okay, so that's what the x and the y thing was. But then you had this. So what'd you have to do? Solve for y, correct? So I'll just write it down. Y is less than or equal to 3x plus 2. That's what you would have gotten for the first one. And then y is less than or equal to negative 2x plus 4. Okay? So then you graph these. You go up 2. Slope is 3. 1, 2, 3, 1. 1, 2, 3, negative 1. 1, 2, 3, negative 1. Again, I want to be pretty accurate with this. All right, so you got this, and then you got this. Everybody with me? Anybody watching? Okay. Oops, I didn't want to do that. That's okay. See, if I click on that thing, I got to come over here and click off of it. Just kind of a pain. I'll just keep it there. All right, and then let's graph the other one. So plus 4. Oh, I messed everything up, didn't I? I clicked on, oops, what am I doing? Click off of that. Okay, it's good there. Okay, this one. So 4, 1, 2, 3, 4, and then negative 2 over 1, negative 2 over 1, Negative 2 over 1. That's good enough. That goes to there. And this goes to there. All right, now here's the key to the shading. Some of you shaded that whole entire triangle. Okay, but remember, it's got to be what? It's got to be to the right of that y-axis. So can you shade anything to the left of the y-axis? No. So this little chunk right there cannot be shaded because it's got to be everything to the right of that y-axis. So you can only shade from there to there, all that stuff in there. All right, so that's why some of you shaded it and I went like that. That's why I did that, okay, because that part cannot be shaded. Does that make sense? So this is not a vertex, right? Well, we don't have to do that anyway with this one. All we had to do is just shade it in, all right? But that's why it can't be shaded. Yes?
Aren't you just supposed to circle like almost underneath both of them?
Yeah, but let's see, this is y is greater than because you divided by a negative. You divided by a negative 3, so you have to change the direction of that inequality. All right, that's why it's shaded in that direction. I made the same exact mistake, so don't feel bad. All right, what are we doing? Oh, you know what? I didn't, yeah. I didn't put it on here, but I'll just write it out. All right, so number 9, I'll just write it out. 2x plus 3y. I thought you guys were getting good at these things. I'd say most of you. I said I thought you guys were getting good at these.
So your bio teachers assigns like 5 essays the day back to school.
Yeah. That's right. I'll give you 5 homeworks when you come back to school. So. All right. So look, this first one, I made it really easy for you. I could have made it a lot more difficult. Okay. Was it? No, you probably just made some little silly arithmetic error somewhere is my guess. Okay. So look, I'm going to take these two. Actually, I don't need that white background, do I? There we go. I don't have to worry about that. All right, so what I'm going to do is take these two right here and combine them together. Right? And then do some elimination with this. It's already set up to eliminate the z's, correct? So that goes, bring this down. What's that? 3x, bring that down, plus 2y equals 22. We're just going to leave that for a second until we come back to it. Everybody with me so far? All right, what's another super easy thing that I can eliminate? The second and the third, right? So I'm going to take the second and the third and do the same exact thing. I'm going to eliminate the z's again, right? I'm doing it to 2 different equations, right? So I'm going to get 2 different x's and y's. So let's do that. So the z's cancel. Add up that. It's 2x. What's this? Negative 3y equals 6. Okay? So those are the 2 things that I'm going to use now. Then I'm going to do elimination with that. And then I should be able to solve for x and y. Then I can take that x and y, put it into any one of these, and then solve for z. All right, I don't need the box now. I'm just going to get rid of that. And let's take this, and copy it, paste it, put it here. See, I told you, you just made a little silly mistake, didn't you? Yeah, that'll do it. Is that because he cheated off you?
Yeah, exactly that.
All right, so What do you eliminate? Doesn't make any difference. I eliminated the y's, I believe, just because one's already plus, one's negative. So I multiplied this by 3, and I multiplied this one by 2. Get rid of both of them? If I get rid of both of them, I don't have any x's and y's left over. I got, okay, so here we go. So I want to try to get rid of the y's. So what do I have now? I got 9x plus 6y equals 66. And then this is 4x minus 6y equals 12. All right, that cancels. 13x equals, what's that, 78? What's that? What's 78 divided by 13? 6. Okay, so there's that. Once I get one, the rest is just like dominoes. Remember that? Okay, this should be pretty easy. So I can choose any equation with an x and a y in it and solve for y. Which one would I pick? It doesn't make any difference. Let's pick this one right here. Okay? So I got 2 what? 2 times 6 minus 3y equals 6. So I got negative 3y. What's that? 12, right? Divide by subtract a 12. So what do I get? Negative 6. Divide by negative 3. That divided by negative 3 is 2. So that's one of my other answers. Now, I can pick any of these. It doesn't matter which one I pick. Solve for z. I would probably pick this one, wouldn't you? Okay, so let's put it in here. X is 6 minus y, which is 2, plus z equals 1. That's a 4. Subtract a 4. Z is negative 3. There's your answer. Write it as an ordered what? Triple, not pair. There's 3 of them. 2. It's not the same thing. All right, so there's your answer. I saved the circle for the actual answer. There you go. Looks like a mess if you just take a glance at it, but it's pretty orderly, I think. Do you? Yeah. I did substitution for the first thing. I did some elimination after that, but I started off doing substitution. I mean, you probably could do it another way, but that's how I chose to do it. Oops. Now, in some of your graphing, if you got it wrong, I didn't necessarily go through and do the whole graph for you. It would have been too messy, and it would just take too much time. All right, so if you have a question on one of the graphing ones, you can check my answer key and look at it. But usually I write the correct answer down if you got it wrong, but some of those would just take too long to do a graph every single time, so I just didn't do that. So here's what I did on my first step. I got x by itself, and I thought, well, I could do a little substitution if I get x by itself. So add a 2z to both sides, and I get that, right? Now I can take this x and put it anywhere. Don't put it back into the original one because everything will just go away. You don't want that, all right? But put it into any one down here with an x. Well, this is the only other one with an x, so let's put it in for that, all right? So it's going to be 2 times x, which is 2z plus 5. So there's my substitution. Do the rest of it. Plus 3y plus z equals 9. Distribute for z plus 10 plus 3y plus z equals 9. I like to put it in alphabetical order, so I'm going to put the 3y first, okay? And then let's put the z's. What's that? Plus 5z. And let's just get rid of the 10 now. Subtract 10, subtract 10. That gives you negative 1. You got that? So what does this have? It's got a y and a z in it, doesn't it? Do you have anything else that has a y and a z in it? Yeah, this one right here. So let's take this and put it right here. 3y minus z equals 1. What would you eliminate? I would do the y's. So just make everything what? Negative, right? Change the sign of everything just so that when I add them up, adds up to 0. Agreed? Cancel. What's this? 6z equals negative 2. Did I do this right? Nope. What did I do? I messed up. Where did I mess up? It's 11. Where's 11? The top one's 11. This one's 11. Yeah. Why is it 11? Oh, it's not a 1. Ah. Why didn't you tell me? Yes, it's an 11. All right, so there you go. So this is what then? Negative 12. That makes more sense. See, that's why I just gave you a great example of anybody could make a silly little mistake, and that's what my mistake was. Divide by 6, so what's z? Negative 2. All right, and then I would solve for x, wouldn't you? Because you know what z is, and you kind of have x by itself, so I would do that. Can you just feel the dominoes just being knocked over? Okay, equals 2 times negative 2 plus 5. X equals, that's negative 4 plus 5, which is 1. And then one more, solve for what? Y. The only place, you could go right here, couldn't you? You want to do that one? So 3y minus z, which is minus a negative, which is plus 2, yeah? Equals 11. 3y equals 9. Y is 3. And there you go. Your final answer, 3, negative 2. And there it is. Please, what are you talking about? I gave you half credit if you missed it anyway, right? You can't ask for any more than that. My goodness. I'm like, I'll tell you what, you're lucky you didn't have me when I first started teaching, because I would have never done something like that. But I'm just trying to help you out a little bit. All right. Any other questions? When are we out of this class anyway? 15? All right, we got 10 minutes or 9 minutes. Is there anything else? Let's not waste our time. Let's do one. Anything on any of these quizzes? What about this last quiz especially? Any of the graphing? Look, you should feel pretty good about the test coming up, right? Tomorrow. It's 20 questions. It's basically one question each from the quiz. It's basically taking the 2 quizzes again, except about half of them are different numbers. All right, half of them are the same. Not exactly. I didn't figure it out which ones, but I would say around half of them have different numbers on it, and then half of them are exactly the same as what we did. Right?
I'm definitely going to be there.
Well, the midterm is going to be doing this again, all right, because it's chapter 3. So it's chapters 1, 2, and 3. The midterm is chapters 1, 2, and 3.
How many questions in the board?
1,000.
40 questions?
40. It's going to be 40. 40. Only? It's 2 tests. 300? Yeah, but did they have multiple choice and all that kind of stuff? Or did you? But you didn't have to do you had to do work for 300 problems?
It was
Well.
2 separate assignments because the computer couldn't register all of them.
Oh, you're doing it on a computer?
No, because you had to do the work on paper and type it in. Like 2 hours.
And you had 200 questions? They couldn't have been they couldn't be this involved though. There's no way it's that involved. Yeah.
2 hours, bro?
Anyway, I could give you 50 I can give you 100 problems if you want. Did you want 100 problems?
40 questions is just fine.
I'm giving you 40. That's what I always do. So I'm giving you 40. That's going to take you, look, 40 questions is going to take you the whole time anyway. I mean, it takes you the whole time to do 20 in one class period. It's basically 2 class periods, and I'm giving you 2 tests in 2 class periods. So, all right, enough of that.